Hello grade 10. Today we're going to be looking at resistors connected in parallel. How does current, how does the potential difference, and how does the resistance behave when resistor or other components are connected in parallel. Remember, this is applicable for any component. We're just going to be working with resistance. All right. So now, previously we did two videos. One of them was just about resistance, in which we define resistance. We mentioned the factors that affect the resistance of a resistor. Then later on, we did another video of resistors connected in series. How does potential difference, how does current, and how does resistance behave when resistors are connected in series. Now, today we're going to be looking at resistors connected in parallel. All right, so here we have a circuit in which we have three resistors connected in parallel. There is resistor 1, there is resistor 2, and there is resistor 3. Okay, so we have a battery. This battery is made of three cells. This is one cell, this is another cell, and this is another cell connected in series. So whatever was done in the previous video, according to having the resistors connected in series, will be applicable for those cells connected in series. All right. Now we have a voltmeter here. This is a voltmeter, and that voltmeter is measuring the total potential difference of the battery. In other words, the EMF. Alright, that is important. Now, let's start with potential difference. Here is a voltmeter measuring the potential difference of the first resistance. There is a voltmeter measuring the potential difference of the second resistor, and there below is another voltmeter. If it's 2, it should be 3. So let's just fix that number quickly. It is voltmeter 3. Okay. Now, let's see the voltage. When the resistors or any components are connected in parallel, the voltage or the potential difference in that parallel part will be equal. In other words, the potential difference across all these resistors connected in parallel will be exactly the same. So this one will be equal to the potential difference of the first resistor, and will be equal to the potential difference of the second resistor, and will be equal to the potential difference of the third resistor. So the potential difference across the parallel circuit will be the same. In this case, because only you have connections in parallel, the potential difference of the battery will be also the same. Right? So this is the potential difference across the parallel circuit. Okay, so let's write down just that subtitle. This is a potential difference for the parallel resistors. I'm going to write just R. Okay, so that is how to calculate the potential difference across the parallel resistor. Now, what happened to current? Now, current, when current comes here, the total current of the circuit comes here, is divided in three parts. One there, another part there, and another part there. So it will be divided in three. So it is not going to be the same as the total current. Okay, so the current here, let's fix that one. The current in the parallel circuit or connection will be divided. Okay, will be, so the total current, I'm going to write current total. Okay, current in parallel, the total one in parallel will be equal to the addition of current 1 plus current 2 plus current 3. So the addition of those current will give you the total current before the parallel circuit. Alright, that is in relation with current. And in relation with the resistance. Let's use black for this one. Now, the resistance in parallel, let's just write here, resistance of resistor connected in parallel. Now, in this case, you have to go to a fraction. So the resistance in parallel will be equal to 1 divided by the first resistance plus 1 divided by the second resistance plus 1 divided by the third resistance. Now note that the resistance in parallel is the denominator. So if you want to fix this one and have only one formula, you can say that the resistance in parallel is equal to 1 divided by resistance 1 plus 1 divided by resistance 2 plus 1 divided by resistance 3, everything to the power minus 1. This is a better way of writing this formula, because then you don't make mistake thinking that the resistance in parallel is the denominator in this formula. So if I were you, I will use the same formula, but it's already in this way, so I can substitute or use it in my calculator. Now, if you have only 2 resistors, which is not the case of this circuit, if you have only 2 resistors, then there is another formula that we can use, but this one is only for 2 resistors. Alright, we can say that resistance in parallel is equal to the product of resistance 1 times resistor 2 divided by the addition of resistor 1 plus resistance 2. Now this one, notice, and I'm going to say it again, this can be used only for 2 resistors. Alright, so this is everything about resistance in parallel, about current in parallel, and about potential difference in parallel. It is not difficult, it is easy, you just have to learn. Once more, I want to record from previous video the Ohm's law. You don't have to stay Ohm's law, but learn the formula because you are going to use it. The current is equal to potential difference divided by resistance. You must learn because you will use it later in some questions. Okay, thank you very much. I hope you understand. The next video will use one example when you combine the resistors in series and in parallel. Thank you very much.